Karthik. My student ID is 22601967 This is my solution video for task 1.1 P, which covers selection statements, if and switch, and casting. I have written 4 programs: if statement, uh, switch statement, microwave, and debugging, and do casting. I will walk through each one quickly and then demonstrate the debugging on the microwave program. Let me share the screen first. Statement. The first program reads the input from the console read line, returns a string. I convert it to integer by using con convert to int 32. Then an if and else if chain checks the numbers. If it's 1, then the program prints 1. If it's 2, then the program prints 2, and so on. If it's like till 9, if it's 9, then the program prints 9. And if it's other than in between numbers 1 to 9, if I type like 100 or 50 or greater than 9, then it prints like error, the number must be between 1 and 9. It will show an error message. Let's try to see the output. Now I'm entering number 4. It prints 4 in Word. Now let me type a number 57. It will show the error message. Yeah. Now let's go to the second program, switch statement. The second program, switch statement, does the same job with a switch statement. Each value from 1 to 9 has its own case ending with a break. In C, requires the break. It doesn't allow fall through from a non-empty case. The default case handles everything outside from 1 to 9. For a fixed set of values like this, I mean, we have the limit right from 1 to 9, like anything. For a fixed set of values like this, switch is cleaner and easier to read, as compared to the if else chains. Switch is easier to read. And let's go to program 3, do casting. Here's the program. Here is the code. The casting program shows why integer division is dangerous. Now you can see the sum is 17 and the count is 5. So the real average is 3.4. So the real average is 3.4, but the sum divided by the count gives integer 3. After this, the fraction is thrown away. Even storing the result in a double still prints 3, because the division is already happened between the two integers before the assignment. The fixed cast sum to double first. Double sum divided by count, which forces floating division and correctly prints 3.4. You can see here in the output screen. Finally, the microwave program. Firstly, it asks for the enter the number of items to heat. number of items. Secondly, it asks for heating time. For one item, it takes the same time as it is. For two, it adds 50% of the heating time. For three items, double the heating time. For four items, for more than three items, heating time, it will show an message like heating more than three items at once is not recommended. Now I have set a breaking point. You can see now I set this breaking point for the items list. Now I will start the debugging process. You can see the debug console asking for the number of items to heat. I'm entering 2. You can see here firstly items, the list of items is showing 0 and the time is showing 0. Now I'm entering 2. The items has changed the items has changed from 0 to 2. Now you can see, and and it's same for the heating time process as well. I will show you. It is asking for the heating time in seconds. I'm entering. I'm entering 60. Now you can see the time has changed from 0 to 60 as well. Now you can watch the highlighted line as I step through the if else if chains. If item equal to 1, it false. It checks items are equal to 1 or not. If items are equal to 1, then it's true, right? I entered 2. So if the it will check is it equal to 1 or not. It's false. Now it will directly go to the else if statement and checks if items are equal to 2, which is true. Which is true. Yeah. This is how it verifies, like until it finds the correct branch to, and then it checks. If I add a logic error in this way, uh, suppose like if I wrote plus 1.5 here, plus 1.5 instead of times of 1.5, I would catch it here by checking the values before anything prints. Now you can see that the time is changed as well. Now I will end this. Now I will end this. You can see here recommended heating time is 90 seconds. That's how debugging workflow. Firstly, set a breaking point and steps through line by line. Watch the variables, watch the variables and confirm the logic. Checking the values before they are printed is the fastest way to find and fix bugs.